Hello, everybody, and welcome to GraphQL Contributor Days. We're really excited for you all to be here. We're really excited to have this group of people again after so long. Feels like it's been a year. It hasn't, but it feels that way. We're really excited to talk about GraphQL today and all the amazing things that are going on in the community and all the amazing things that you all are doing. Before we get started, though, of course, we would love to thank our sponsors, This.Labs and Hasura. Tanma, you want to talk a little bit about Hasura?
Hey folks, glad to be here and glad to be kind of helping host this event again. Hasura is an open source project where we're kind of working on providing GraphQL APIs on your data sources, multiple data sources automatically. So do check it out on GitHub. And otherwise, we're happy to be here and kind of dive into more conversations around GraphQL and related topics over the coming hours.
Awesome. And This.Labs is a JavaScript consultancy, and we love working with our clients to build out their GraphQL solutions and are really excited to help facilitate this conversation. Coming up in the GraphQL ecosystem, we have several events. You can check them all out, but you can learn more at this.media.com. And today, Tanmay and myself will be your hosts. My name is Dustin Goodman. I'm an engineering manager at This.Labs. Tanmay, you want to introduce yourself?
Hey, I'm the founder CEO at Hasura.
Yeah, and we're just really excited to kick this conversation off. And we have just an amazing group of panelists, and we wanted to let them introduce themselves, starting with Mark.
Yes. Hey, everyone. My name is Mark. I'm joining in from Montreal, Canada today. We've got snow here, as you can see already. I'm a software engineer at Netflix, where I work on GraphQL there. Lots of federation stuff. Yeah, that's pretty much it.
Patrick, you're next.
Oh, yeah, sure. Yeah, my name is Patrick. I'm currently a software engineer. I'm not working, just quit my job to find something new. And I'm joining from London, and I'm a maintainer of a Python library for GraphQL.
I think Natalia isn't here quite yet. Tejas?
It's Tejas.
Sorry.
Hi. You're not the only one. Hi, Tejas here. I work at Spotify, even still today. But I'm on my way out. And at Spotify, we use GraphQL to build out a platform called Backstage, which is also open source. But the internal part of how we use Backstage uses GraphQL at Spotify. And it's a lot of fun to kind of use the graphical user interface, GraphQL, to explore our service architecture. As you can imagine, we have a ton of microservices. So GraphQL helps service discovery quite a bit.
I guess I'm next. I'm Uli. I'm a member of a group called the Guild. We maintain a lot of open source tools in the ecosystem, GraphQL code generator, GraphQL tools and schema stitching, GraphQL mesh, and many others. And recently, new server infrastructure, starting with GraphQL Helix and Envelope, and the new GraphQL Yoga that is going to be out soon. That's it for me.
Hi, everybody. My name is Andy. I'm working for Atlassian on various GraphQL topics, but I'm also the founder and maintainer of GraphQL Java and, yeah, a general GraphQL contributor over the years.
Hello, I'm Gabriel from Sweden. I work at an IT consultancy and startup incubator called Arison. And I also maintain a open source library called the Rescript Relay, which marries together Relay, which I guess you've all heard of, the GraphQL client from Facebook, with Rescript, which is a programming language that compiles to JavaScript. I also run a meetup for Relay online, which is not very creatively called Relay Meetup. So that's me.
Hey guys, I'm Joey. I work at PayPal. I live in Austin, Texas, and I'm on the web platform team leading the GraphQL efforts for supporting frameworks and tools. And our most recent effort is around a unified graph at PayPal.
Celeste's not quite here.
Hey, I'm Connor. I work at a firm. A lot of times when I say that, people think it's just a firm, like any place, but it's a real company. It's pretty much that button you see everywhere telling you can split your payments. I work on the account experience team, and right now we're a recently formed team, so we're kind of putting our APIs together and kind of pushing for GraphQL the middle tier right now for us as we combine all these disparate APIs that existed beforehand. So I find myself in a familiar position at a company trying to get them to use GraphQL.
Roy?
Yeah, that's me, I guess. So I'm Roy from Amsterdam, the Netherlands. So end of day here. I have working with GraphQL quite some time and recently joined a company called StepSend, which is a tool to create a GraphQL API from any data source. And well, yeah, I just love GraphQL and creating content around it, like basically on all different ways. So happy to join today.
Everyone, my name is John, calling in from Washington, D.C. Formerly senior staff software engineer at Coursera, and now fun employed, but most recently working on guiding the company through federation, kind of pulling up some new stuff with DGS, doing the whole Netflix thing, as well as doing some consulting and advising in the GraphQL space too.
Hey, I'm Jamie. I work in developer relations at GraphCMS. I'm from the UK and I've been spending a few kind of months working on creating content around GraphQL. I'm excited to be here and talk with you all.
Hey, I'm Aditi Ravichandran. I live in Kansas City. I have a consulting company called Surya Consulting, and I basically help teams transition to GraphQL, transition to React Native, and Cypress. I got into GraphQL a few years ago in a previous startup that I worked for, and I really liked it. And I also have some courses on GraphQL on Pluralsight. So that's pretty much what I do, make courses and help teams transition to GraphQL and React.
My name is Kyle Sharati. I'm a software engineer at StockX in the Detroit area. And we recently have been trying to really scale our graph to handle the load at all times. That's been our biggest thing, as well as starting to educate other people. So we had a nice group of people that know a lot, and then we're trying to just spread that knowledge out and make it easier for everybody else to add on to their stuff through some cool code gen and automation of a lot of processes.
And Tim will be joining us later, I believe, but it's really exciting. Thank you, everybody, for your amazing introductions. For everybody following along at home, this is roughly the agenda that we're going to be talking about, but it's a free-flowing conversation, not necessarily one we're going to stick to in any particular stringent manner. But definitely we'll take a little bit of a bio break in a little bit, but we'd love to kick off today with some community showcases and updates. And I believe Gabriel and Uri both have amazing demos for us. Uri, I think you want to get us started?
Yeah, I didn't prepare a demo. I just wanted to say that this week we're gonna launch GraphQL Yoga. GraphQL Yoga used to be like a very popular backend framework for GraphQL, maintained by Prisma. And with the time, Prisma moved to other things, and they were kind enough to basically talk to us and see if we have a vision for GraphQL Yoga and where it could be taken on next. And in the last few months, we actually took Envelope, which is the plugin system that we wrote for GraphQL, which is a more, you can think about it as more kind of like low-level framework for frameworks, like, for example, Redwood.js just recently migrated from Apollo, using Apollo server under the hood to Envelope. But for people who actually want to start with building GraphQL software super quick, Envelope might be, so for us, we use it just as a regular framework, but for some people, you know, they might want something more out of the box, batteries included. So we worked in the recent months to create basically GraphQL Yoga 2.0. It's still in a branch, but this week we're gonna basically release the first alpha. And it's really batteries included, meaning like it includes not only like the latest versions of everything, but also out of the box, it includes support for different stream, live queries, and also the latest graphical that supports all of this. And an actual graphical that runs locally and not in the cloud. I'm really excited for this, and I'm going to announce it in GraphQL Galaxy, and it's still in an alpha phase because we want to actually get the community to try it out and tell us what they want from a batteries included framework. And we're really excited about it. We think there's still a space for let's say a batteries included framework that actually is being worked on for the long term, constantly being up to date. The maintainers are hearing the feedback from the community and actually keep things updated. So yeah, thanks for giving me the opportunity to announce it. If people want to like track it, just Google GraphQL Yoga and go to the repo. Later this week, master will be updated, but until now, there's a PR that is ready basically to use. Thank you very much.
That's really exciting. Thanks for sharing. I know Gabriel also had a pretty cool showcase that he wanted to share with us today.
Yeah, let me see if I can share my screen here.
I think I made it so you could.
Yeah, do you see my screen now?
We do.
Oh, excellent. Okay, so a bit of background. As I mentioned in my intro, I maintain an open source project called Rescript Relay, and Rescript is a programming language that compiles to JavaScript. And like some of the main benefits of it is that it has a very strong type system and very good type inference, and a very ergonomic syntax, especially for building UI stuff, and good integrations with React. So you use Rescript instead of or in addition to JavaScript or TypeScript, basically. And the project itself is about using Relay together with Rescript. And I've built a CLI that can basically go through your entire Rescript Relay project and automatically remove any fields, any selections from your queries and fragments that you don't reference in code. So basically preventing overfetching. And it can do this quite well because you can always, because Rescript has such a strong type system, you can always trace back any value inside of your program to an actual position in a GraphQL operation. So I'm going to demo when I ran this on a project that's kind of mid-sized. It has about, I think at the time, it had about 200 to 250 GraphQL definitions in it, fragments and queries and whatnot. And I'd also like to mention that since I've been doing this for quite a while, I like to think I'm very mindful of removing things that I don't use anymore, but it's impossible to remember to remove everything. So this will run the CLI. Let's see here. And the CLI will go through the project and it'll automatically remove. And you can see that it removed 34 fields from 25 files. And I will see the diffs here. So it has found a bunch of values that I don't reference anywhere in the code, and it can automatically remove it. So it's basically a way of preventing overfetching, and it also comes with a a CI action. So you can put it in your CI and then just make sure that you'll never ever ship anything to production that you don't actually use. And that's, yeah, that was it.
That's awesome.
Thank you.
I know you mentioned it's made for Relay. Is there any possibility of it being accessible through people using Apollo?
It is no. I mean the same principle should apply. Like it's the same type system and whatnot. I just haven't built it since I use Relay myself, but it should be possible to build it for that as well, adapted to that.
Awesome. I was just curious. I use Apollo more than I use Relay personally, and I was like, no,
most people do.
Yeah. Do you have a GitHub repo that we can all look at this that I can share out?
Yes. I can write it in the chat.
Thank you.
Bring it up. The other thing about the type system is it enables quite a lot of interesting tooling. So, for instance, I have a dedicated extension for Rescript Relay, VS Code extension, which can, for instance, like autocomplete unselected fields in the values themselves. So like you're in Rescript code and you're outputting something from an object and you get an autocomplete both for everything you've actually selected on that type, and then you get an autocomplete list also for the things you haven't selected. And when you select anything from that list, it automatically inserts it into the operation. And so kind of like combining those two gets you quite far with like not having to deal with GraphQL operations directly.
Question, are we doing questions or are we going to keep going? Or?
Ask your questions.
I'm curious. I have not used Rescript in any meaningful way, but I'm curious about the kind of GQL-less approach where it seems like there's kind of, you're vacuuming up these extra fields and ultimately you already know whether or not you're using it. Could you just do the opposite and generate the GraphQL query from the usage of the object?
I've been trying to experiment a bit with this. I think it should be like possible, at least in a fairly basic sense, but I guess the problem always becomes when you have potential, like a potential of lots of code points that you touch. So it's hard to know exactly what you're supposed to, like from this route of using something, figure out everything that's used, all the dependencies of it, without actually overfetching or underfetching. But like theoretically, something should be able to build with the setup that's there.
Makes sense. Thanks.
Sweet. Cool. Awesome. So I think those are the updates. I think we had a topic towards the end to cover. Dustin, I think on the agenda we had like the GraphQL Foundation stuff towards the end, but maybe we want to bring that up, and if we're doing community updates, maybe we just want to go through any of the GraphQL Foundation updates or GraphQL spec updates that folks want to share.
Some of the foundation members are joining a little bit later, so we were going to defer those updates until that point, if that's all right. But I think we're all most excited about those updates, so definitely can't wait for them to join. But that being said, did anybody else have anything and I've lost my words now, community showcase or update related, even if it is foundation related?
I had a small update to share, is that we're kind of building out we're building out some work on supporting streaming kind of use cases with especially for like really large API responses, not just from a API latency point of view, but also like if you want to just stream out like hundreds of thousands or millions of entities, and you want to kind of gradually get that stream and stuff. So we've been seeing that use case fairly often, and streaming felt like a good fit. One of the questions that I had for folks, anybody who's implemented either at stream or something like streaming over GraphQL, have you been using kind of the at stream directive, we tried to do that, but then we decided to start off with using subscriptions and WebSockets instead, because that'd be easier. Primarily because I'm not sure how folks are handling back pressure and things like that. So because back pressure becomes hard to handle, so we just do it with WebSockets, and it's easier. But I was just wondering, on the streaming side, have folks had any implementations, especially at scale, what that's looked like, and a specific technical question around how people are doing back pressure, or if they're worrying about that at all?
I can start off with a small snippet. So at PayPal, we decided not to use subscriptions or stream for, like, we have a chat application for a specific product we're working on. And we just basically, for that streaming part, we use a WebSocket completely separate from our GraphQL layer. So we haven't decided to put it in. Curious to hear what are your guys' opinions for putting it in the GraphQL layer also.
I mean, one good reason to put it in your GraphQL is that the data that comes from it, you can then merge it into your store. So basically, let's say you're now getting an update from like a subscription, like let's say you have a chat message and a new message, then you can propagate it immediately to the store, and it will be normalized, like with a bulk client or Relay or Urkel. And then it will just be handled as any other data that you get throughout your regular API. Doesn't matter if the update is push or pull.
I will share that I've had some personal difficulties getting subscriptions to work on different hosting services. I'm a big fan of putting GraphQL specifically on AWS Lambda through serverless, and Gateway doesn't support sockets very well, especially with the non-persistent connection, making it a bit difficult to particularly perform at that way. So that's definitely been a reason I've opted for a separate WebSocket in those specific instances. But like Uri said, I would much prefer it to be through the GraphQL layer because it does manage my stores and states for me. So that's definitely been a challenge I've been looking to solve. I haven't found a solution I like that doesn't take weeks of engineering.
Sorry, Joey, the question that you had about in the GraphQL layer or not, I don't think I got that clearly. What was the
like using stream, defer, or a subscription, or live, or whatever it is, so that you're still using the same GraphQL endpoint. And like Uri said, it's going through the same layers. So your whatever store you have connected to GraphQL. Right now, it was hard, so we just didn't do it. And we're using an Apollo gateway as well, so that's part of the complexity. But yeah, if you're curious to see if anyone has solved that, and I think Dustin, you just mentioned the same thing, right?
Yeah, the way that we had solved it, because we were on AWS, we leveraged DynamoDB's stream, and we're able to publish updates through API Gateway directly from Dynamo. But it wasn't the easiest of solutions, and it took a couple weeks to get it just right, and definitely saw some latency issues with it. So it wasn't my favorite solution, but it was a functional one. So yeah, I'm also curious if anybody else has a solution to this that they've explored.
Yeah, I think for subscriptions type stuff, we've just fallen back to having like containers that scale out very quickly. But like improving that time for a graphical system to like spin up and scale out seems to be easier with the existing infrastructure to get WebSockets type stuff working than anything else. The other thing I've also seen is some people using some of the worker stuff on CDNs. Like I think I'm not sure if this was with Fastly or with Cloudflare, but you terminate this. You do the WebSocket stuff with the CDN layer, with the workers at the CDN layers, at like kind of these edge cloud type layers, and then you don't have to do the socket stuff yourself. And you terminate the socket, the persistent socket at the CDN. So I'm not I haven't had any experience with it, but I've talked to a few folks who've been trying something like that out.
So not necessarily for serverless environments, because then there's all kinds of other things to think about, and we can get very deep into that discussion. But in GraphQL Helix, we basically now support, basically we have built-in support for subscriptions using SSC as well, and not only WebSockets. And overall, like we kind of like rebuild the whole network mechanisms there to build on the W3C standard. So, you know, you could basically run that setup in any environment, like, you know, Cloudflare Workers, Node, AWS Lambda, and all kinds of other weird places. So, and we are investing, and when I mentioned Yoga, like we are making sure that everything there works, including subscriptions. In terms of like, should you use subscriptions over serverless environments? It's so today you can with these libraries, but the question is if you want to do that. But what I would, but in as a general comment, it's much easier now. It's you know, while other frameworks dropped support for it, we now have, you know, built-in support for it. And also handling the network as just how the network is supposed to be and not tangled into the framework itself. So it's also very flexible. You can choose whatever transport you're using and yeah, you want and things like that. So if you tried it with other frameworks and you haven't tried it with Helix or Envelope and Yoga, I highly recommend you to try again.
That sounds awesome. And just to shamelessly plug my other question, and again, has anybody been thinking about flow control type semantics with subscriptions? Like I realized that one of the reasons why we didn't have to think about it early on is because by default, the kind of subscriptions that I did today that we were working on were more live query style subscriptions, where you don't need too much explicit flow control because you, in a live query, you understand the size of the response that you're going to get. So you have a sense always of like, that the size of response that you're going to get, and you're in some control of the frequency with which you're getting those updates. But if you start streaming stuff and you're sending like thousands of events or hundreds of thousands of events, like, is the client ready for handling that? Does the client have a way of saying, please stop, I'm still buffering, right? The way that like a normal stream flow would have. So have any of you run into problems like that, or thought about anything that you're using? I was checking out the new WebSocket API that supports streams, like WebSocket Streams, which has some support for backpressure built in, but that's only on Chrome. But HTTP2 and SSE, I have no idea how backpressure or any kind of flow control would work. Yeah, I see what you're saying. Just don't care about the client, just nuke it. It's okay. Send it all the events. If it memory overflows, it's the user's device. Who cares anyway? This makes sense. This is good.
Yeah, and also like what is like a use case where you bombarding a specific client with so much information?
Like I open up my Slack after a really long time, and I have like a stream of events that come in, and it's like 2 billion events that suddenly come in because I opened it after a month. And my 2G breaks, my battery dies, my 3G breaks, my 4G breaks, 5G also, like nothing will happen because it's like a billion events after a month, right? So that's a good one. That's what I meant. Because it depends on kind of how fast the client can consume to render something, right? Like maybe it can't render the list fast enough to even consume the stream. So
it's interesting. I never got into this issue yet, but it's very interesting.
But anyhow, I think that was on those are on kind of some of the stream defer style updates that I want to talk about. But otherwise, I thought we could dive into maybe the first part of our thing that we kind of traditionally just touch upon, a little bit of GraphQL onboarding, GraphQL learning. Any insights that folks would like to share from the last time we chatted, or the last maybe 6 to 12 months on new things that you've been doing that have been kind of helping you accelerate GraphQL onboarding, not just for people who are using GraphQL for the first time, but maybe even other stakeholders in your organization, like folks on the ops side, on the infrastructure side, to kind of get ready to deploy and use GraphQL internally. What are you seeing as things that are being successful that might be useful to kind of share with the rest of the folks here and for other folks on the live stream as well? So any thoughts on the GraphQL onboarding and GraphQL learning side of things?
I have a little bit I can share. So we did two things in the last year that have been really, really impactful. One, we started, it sounds really dumb, but we created an internal wiki for just our GraphQL servers and how they interact. The amount of questions of people just asking the same thing over and over is kind of crazy. And if you just document it, it's very easy for somebody to self-learn at their own pace. And if they need to go back and look at something, they can do it. So that's been, hugely impactful, is just doing that. The other thing, which has been surprisingly better and better as time goes on, is we've created code gen around creating a subgraph for any of our stuff. So a lot of times if people come to us and you say, I don't really know where this fits, maybe we should make a new one. And immediately it's, I don't want to stand up a service. I don't want to make it ready for load. I don't want to do any of these things, right? So the easiest way to do that is just create a code gen. You run one CLI command and all of a sudden you have your own subgraph and you can move on. So those two things have been immensely helpful for just either helping train people or people who know what they're doing already, just move at a faster pace.
Got it.
I can jump in as well. One of the things that I've seen over the last sort of 6 to 9 months is a huge increase in content for those new to GraphQL as well. And it's really great to see there's so much kind of so many kind of things being shared on best practices and helping people get on board in using GraphQL maybe for the first time. In the position that I'm in, I speak with people on a daily basis who are new to GraphQL and they're looking to kind of consume a GraphQL API. And there's actually a huge amount of great content that is being created by so many people doing some great stuff. Roy, I've been watching some of your content and reading some of that, which is great. And I know the Guild recently kind of released a tutorial on the how to do GraphQL site, which went some time unmaintained or whatever, but it's great to see content being kind of contributed there again. And I think for anyone watching and listening, that tutorial covers Helix, I believe, and building a service. That's really cool. And Tanmai, I know that the team at Hasura, you released something new with the docs on onboarding people with GraphQL and the different frameworks. That's really, really cool. And yes, it's kind of using Hasura, but what other better way is there to learn all these different frameworks to just kind of have something with GraphQL running and working, and you can learn about the stuff on the front end. And there's so much stuff going on in the GraphQL community. If someone is new to it or kind of intrigued by it, there's a lot of great content going on. I think the guys at GraphCDN recently took over the podcast that the Prisma team ran. So we're going to see more content being created in different formats, which is, it's just great. What a time to be alive, they would say.
That's great to hear. And thanks for the note there as well. But I think in terms of kind of like helping people get started with GraphQL and stuff, right? I think there's I think there's like a lot of work to be done there, and it's sort of kind of organic as well, because the community needs to figure out what the community doesn't know, in a sense, right? It's like, what are the gaps that we need to plug? Well, we find it, and then somebody will help kind of plug that gap. And I think that's been awesome to see. I think some of the challenges that we've been kind of facing are more around kind of a lot of kind of like these how to operationalize GraphQL, because those people are so far removed from wanting to learn new things often, right? On the ops side, they're like, nope, I don't want to figure out how to modify my log service or my metric service to make this work. So I'm wondering if folks have had experiences doing that on like the GraphQL onboarding for like not the GraphQL developers or the GraphQL consumers, but other GraphQL stakeholders also, like the ops people, for example.
What do you mean by the ops people? The people running the actual services?
Yeah, like people running maybe other services. Like, I don't know if it's impacted them even, right? Like anybody who's like helping out with the APM side of things or the alerting side of things, right? Like, are they impacted at all, or like, are they impacted by the GraphQL thing at all? Like, especially if you're running in a security sensitive context and people care about like these SIM events, right? Like security events. Like, how are you folks thinking about like, is that a problem? And then like, how does that happen?
Yeah, I definitely think it's a problem. I think there's a lot of semantics. HTTP 200 is one of those things where it's just, you get these kind of blanket, this is a successful failure kind of deal, where it just doesn't quite follow the natural HTTP thing that most folks are used to. So, your GraphQL server can be up and just not work, particularly well. There's also other security concerns that we've run into as we've had like security folks looking at the servers. So like, introspection schemas are one of those things where it's kind of like a low-hanging fruit that you're not thinking about, but will leak your entire schema. There's multiple ways of getting that introspection. There's a bunch of other introspection fields that you need to block, but you also need it in certain cases for tooling. So it's like there's like a long checklist of after you've got, you're like, congratulations, you have your server, but like there's a whole long tail of all the little things you got to think about between that server and the next step that I don't think there's a concise thing. Like, so for example, I've been talking a lot with GraphCDN, and as a CDN, they have to they want to be able to use the schema. They want to be able to help people build and deploy really good GraphQL servers. And so really they have to think about this advanced checklist of all those pieces. And I realized just how many different things there are, because there's things like persistent queries, like lots of things like that. And I don't think that there's a concise resource that gets you through that entire checklist.
Yeah, I agree. I would add to that like it's not only, in my opinion, just like an educational issue or a knowledge issue, but I think it's also a bit about how we structure things today, where we can't hook in many of the tools we're using today. We can't hook into the life cycle of GraphQL. It's like we're doing everything before or after. And one thing that really helped us, and that's kind of like the reason we created the envelope. And again, I'm not trying to plug this thing. I think actually this is something that other people from other languages should copy or should look at, is hooking into the life cycle, because then not only that you can come up with a resource or explain how to do things, but you could actually create a piece of code that could be reused no matter what tool you're using. And then that's much easier to share. Some examples about, you could hook into the introspection phase, and you can do all kinds of things that, let's say, for us specifically in the JavaScript world, maybe GraphQL JS is limiting us in some ways, or there are some features that are not existing yet. And it's hard to do for whatever reason, but it might be easier in, I don't know, in other languages or other ecosystems. I think hooking into that system can actually make it easier. You can write a very good article about how to do things, and then also offer a plugin with that makes it very easy to use and support these things. Yeah, I'll share some examples of guides we wrote on the envelope website, which I think are good examples, because we explain what it means to I don't know, secure your GraphQL API, but then also gives you just a couple of plugins you can just install, and it's kind of makes the work much easier than I don't know, a fancy conference talk or a really cool blog post, but actually something that you could easily solve. And hopefully that could be a new that could also lead to kind of out of the box experience, right? Right now, the out of the box experience of using GraphQL is, everything is open. You're not using persistent queries. There's all kind defaults are very unsecure. Here you could basically build a default that is by, it might not be the best for everyone, but it's a bit better, I would say, than the current starting point where people are getting started with.
Yeah, that's definitely something I noticed was like every time I bring GraphQL to a new team, which I think this is like my third time, is that GraphQL still hasn't really gone to that point where it's like you're not kind of either choosing something or building something out kind of from scratch. And like no one really agrees on what that thing is if you're choosing something. Like React finally got to create React app, right? Which isn't great, but there is something. GraphQL, I feel like, does not really have that yet.
Especially given that you could make it, as Yuri is saying, is something that's language agnostic. I think you get some folks get lucky and they choose a thing like GraphQL Java, and like Andy Mark and teams done great work on that. And so you benefit a lot from all that stuff. But if you are in another language because of your backend servers or whatever it is, then you're stuck behind the times by default, and that kind of doesn't set you up for success.
I'd like to plug in some more community resources and courses. So I've noticed a lot of the people who, I work with, the clients, they basically have a hard time even at the beginner level with GraphQL. So they are in the REST environment, and a lot of the times they're looking to just, consume a GraphQL API. And they have questions about, which one do we pick? Is it Apollo and things like that? So just resources that help get started and at least set up halfway is like, they could still have some REST parts. They don't need to completely port over to GraphQL. These are things that some clients aren't, fully aware of. And that's where a lot of questions come from my clients. And a bunch of us Pluralsight authors also got together and created a bunch of courses, all related to consuming GraphQL from the client perspective. And these are available on Pluralsight. And I've also noticed that Evie's courses on LinkedIn are also a big hit among newer people who like to get into GraphQL. So we do have a ton of resources, some free and some you have to subscribe to, but there's tons of content, at least from the perspective of consuming GraphQL.
You actually brought up a kind of interesting point where some of my clients and some of the people I've been working with are missing kind of the power of just what fields can actually do in a GraphQL environment. We're stuck in this REST mentality of I can only return the entity and the data around that entity, but with GraphQL itself, we're able to return more than that. We can return the business logic from the server. We can resolve it in whatever way needed for client consumption. And I think that's something people forget. Does anybody have any resources they really like to teach that concept to others? I know when I talk and I present on GraphQL, it's definitely part of my conversation, but it's not one that I can go and point and be like, hey, look at this thing that somebody put out there that really supports this.
I sent out a link, which is basically a whole path of courses on Pluralsight. And the very first course talks about just generically, like, what is GraphQL, the tech agnostic part of it, which is like a big picture. And there we touch topics around, what really is the difference between GraphQL and REST, and, getting them into the, mindset of GraphQL, basically.
I have a question for I think Mark and Joey in terms of like some of the other this kind of GraphQL onboarding stuff, because I guess it's been like a few years of like GraphQL kind of penetrating the organization, right? Like what has it been like? And Mark, given that I think like you just joined Netflix, like what was the onboarding for you like to understand what the internal GraphQL stack is like as an advanced GraphQL user already, right? As somebody who's already familiar with GraphQL, but like getting to the Netflix flavor of like GraphQL implementation, right? So would love to hear from both of you on like what that's been like and any learnings there.
Sure, I can start. Yeah, that's a good question for somebody who's used to a GraphQL stack somewhere, then joining a new company with kind of a different one. I think for me, one of the biggest differences, I was coming from GitHub, which was a giant monolithic graph, to a giant federated graph at Netflix. That was kind of the main difference, and kind of like what it entails in terms of observability and how people are building graphs. So, I mean, the team I joined is just amazing. So they were super helpful explaining context around it, what they've built. Great docs were there already. And then I think for me, what was useful was like thinking of the problems I had before in another team and just asking like, how are you solving this? And then figuring out how it works at Netflix. But in terms of, I think I want to touch on something John was talking about earlier with the 200 OK, I think is the infamous example of if you observe a GraphQL API, like the REST way or just like the standard HTTP way, you can get into trouble, right? And I think that's definitely one part we probably are missing a little bit of information about, is how do you observe a GraphQL API? And with federation, that's even more complex. But even a GraphQL API, like a simple monolithic GraphQL API, can be quite a black box if you just get started quickly. Like we have great docs to get started quickly with GraphQL, but then when you deploy it to production, if you only have a graph that's /GraphQL and you get performance for /GraphQL and you're looking for 500s on /GraphQL, it really doesn't give you a full picture. So I think, and you touched upon this too, is like, are there errors happening at the parsing state, validating GraphQL query, custom validation rules? Is it a server error? Is it a client error? Do you have errors as data, which you would need to observe the response itself to know if it's happening? So there's a ton of stuff happening here, I think, and we probably need to build both better docs on what to observe and tools that help you do that. And Netflix is great at observability in the first place, I think, and I think what a team has built for GraphQL too is great. So there's one concept I want to talk about that I think is super helpful for GraphQL observability, is just the concept of query signatures and query signature hashes. So I think for REST, like you want to see what's going on. There's a problem. You'll see, oh, like the /users path is having issues. With GraphQL, you don't have that out of the box. And I think that's the query signature concept, that is basically, hey, this query shape, no matter what the variables are, is having problems, or this certain field is having issues. But fields, sometimes they don't give you enough context to know if something's going on. So I really love the concept of query signatures and being able to pull traces out of a query signature, and that kind of stuff. So yeah, I think for me, observability is a big one.
And Mark, the query signatures thing that you're talking about is something that is getting implemented, or is that like a wish list of like a thing that like you're imagining exists?
It's implemented.
Oh, okay,
So yeah, there's the query signature, the query plan as well, if you're doing federation. But query signature is just basically just a sorted without variables, and just so that similar queries share the same signature hash. So from there, you can like build that into all your tooling, right? Like if you have metrics, you can tag by a query signature. If the cardinality is not too high, you can go from a query signature to a trace to any sort of things in your tool. So it's pretty amazing.
Yeah, no, that sounds awesome. And just to double click on that a little bit, like what are the kinds of errors that, or like insights that you would get from query signatures that are that you would like, that would be harder to get from just like a field level analysis, right? Are there interesting things that you've seen in practice? Like I'm imagining things where you have like certain dependencies between fields that cause a certain kind of weird behavior, right? But I'm wondering, like in practice, what kinds of like things you've seen?
Yeah, I think, I think you touched on it. Like the dependencies between fields are often, like almost everybody's using data loader, for example, which already kind of like muddies the water in terms of relationship between fields. Or even if you're crafting like SQL queries based on a shape of queries, for example, that will depend on even the ordering could be tricky. And in a differ world, in a streaming world, there's a lot of things that can happen. And I think query signatures are just like such a close mapping to what we had as a resource before, an endpoint,
Right.
that they usually help out a lot.
Awesome. That's very interesting.
So I'm probably not going to sound as put together, because we basically we're kind of feeling things out as we go here at PayPal, and we thought that we could get away with Apollo Studio and like Splunk and Signal Effects the way we had it, and that didn't pan out exactly. So now we're kind of in this like, okay, what do we do now? How do we solve this? And the reason why we got in this is because we were leveraging Apollo Studio for that visibility of 200 errors, because they have, I think, a concept like you're talking about of operation signatures and grouping things and figuring out which operations are failing, things like that. We thought that was great, but two things happened as we started to like lean into that. Was that it didn't scale to like federation. As soon as we had a bunch of subgraphs on the same graph in Studio, we realized that it doesn't actually, you can't like say I'm this subgraph owner and I only care about this subgraph. It like looks at the gateway as an entire graph and does the metrics that way. So I will be pushing on Studio to kind of solve that subgraph story. The other part is that, and they made a good point, that it's like Studio can only see like response shapes and things like that, so it can't do a whole lot. So you're still going to have to supplement that with some sort of like tools inside the resolvers where more is happening than Studio can possibly understand. So we're kind of filling that story out now, like what kind of plugins and logging do we have to use, and where do we put that? It's most likely going to end up all in Splunk and Signal Effects. Like that's probably going to be our primary place for observability, and we'll have to like I said, add a bunch of tools and some standards around how you deal with errors and how you log them. But that's where we are headed. Oh, and another interesting thing I just want to throw out there is not just 200s are hard to watch, but as soon as people start saying, and I think I see it on the side here, Sasha for president. So as soon as people start putting errors or whatever you want to call them inside of their schema, and they also want to understand when those happen, that's another problem. Like, okay, so there is something that we're working with Apollo on, I'm asking for, and they're probably going to make, is this response shape tracking, where you can say like, I care about these things and I want to be alerted on different shapes of responses. So that gets kind of interesting.
One thing that we've done recently with a client of ours that used Apollo Federation was we basically took the Federation execution from Apollo source code and actually replaced Apollo Gateway with Envelope. So Envelope just was like a drop-in replacement for the Apollo Gateway managing the federated services. And that just gave us more hooks into what's happening on the gateway. So we could write all kinds of like custom plugins to start just looking deeper into what's happening and then sending it to their, whatever tracing system they're using and login system they're using. We just started to do it. So, but it looks exciting. I mean, it's maybe they could also later build in the same hooks.
Yeah, and I'm really interested in using a lot of this stuff, Uri, that you're making, and I would like to kind of champion the guild and Apollo can play together, because I'm not like super cool with these two-sided things. So yeah, I'd love to blend a little more.
I wanted to mention, by the way, at the beginning, like people ask for like really cool resources and stuff. I think GraphQL WTF is like one of the coolest things that happened recently in the community from Jamie. It's really cool. Like the videos are, I think it's like the best, most concise and efficient knowledge videos I ever seen.
Yeah,
and
I also just came across it. I was just about to mention it. Thanks, yeah.
So
maybe the domain name wasn't the best, but it sticks out.
Yeah, so just Google GraphQL WTF. It's really cool. I highly recommend it.
Yeah, thanks, Jerry. I think one of the reasons why I started that was literally at the time, a few months ago, I was kind of thinking, what can I read to kind of get started that's kind of just concise? There was a lot of kind of written documentation, but video tutorials were quite old. There was a lot of kind of video tutorials on YouTube showing people how to get started with yoga, the other version. So it's great that there's a new version. I can't wait to create a video on that. But a lot of the content in video format was kind of outdated, or it was too long. So, and while that long content was really great if you had the time, what I kind of decided to do was just kind of create short, concise videos that show people maybe how to do one thing. So the reason why I'm here today really is just to absorb the knowledge of all of you and try and go in, learn, and dive deep on some of those topics, and hopefully share that with people who don't know that as well. So, yeah, thanks for the shout out. But I'm looking forward to all of the content that everyone creates.
Awesome. So we were talking about GraphQL learning experiences, and we use that to kind of talk a lot about other related topics as well. One of the items we had next was talking about just kind of diving a little bit deep and just doing a little bit of a round the table update on what folks are seeing with authorization security at the kind of GraphQL layer, and generally kind of sort of alongside it as well. So we can move into that topic if that sounds good, Dustin. Does that line up with the agenda? Like our time?
Yeah, that works out great.
Awesome. So yeah, would love to hear how folks have been approaching authorization security. If anything has changed over the last few months and years on kind of internal approaches. Things have become kind of more problematic, or things have become simpler by going down a particular route. I think to just kick that off with an update on kind of how we're thinking about it. I think we've been seeing a fair amount of success with model level authorizations. The idea is like whatever the authorization rules are all specified with a model, and then as the resolvers try to fetch or try to resolve parts of those model, the authorization rules then kind of kick in and compose automatically, so that it doesn't matter if you do like query users or query comments.user, the same authorization policies get applied, and there's an opportunity for doing a fair amount of static analysis in deduplicating kind of repeated authorization rules and stuff like that, which makes the data fetch and the check a lot faster. So there's some interesting things there, but that's kind of been working. Like I think that's been a very interesting pattern that we've been following that's been working well. But that's on the authorization side. Anything that you folks have been looking at when it comes to authorization and approaches or questions that you folks have?
Yeah, Tom, I'm curious. From what I've heard from your talks, you provide the data sources as well. So doing the authorization with the data models makes a ton of sense. Does this fit in well with like people who already have like a REST or a gRPC layer, and they're trying to make, which is another common way of, where GraphQL pops up is, oh, I've got all these disparate systems and I want to put a layer on top of it.
Yeah.
I'm curious about that because that's what we're doing. So I'd like to hear more about authorization strategies when you're doing that versus, here's my schema, give me my data sources. That's great, but we don't have that.
No, that makes sense. I think what we've done for services, when we're bringing kind of models that have been specified by services, but that are not kind of serviced by some kind of data model or physical model underneath, right? Where you can't really do any of the query optimization type stuff. We do more of the field level, kind of the schema filtering, right? Where where you have visibility on certain fields, but that's the policy that we attach at a model level. We're not like, it's not feasible to attach any kind of business logic style authorization policy at that if the data is coming in from a service, right? That's been hard to think about. The only kind of idea that we've played around with a little bit that I've seen also in industry, not in the GraphQL space, but like in the data space, has been that you effectively have to kind of materialize that service internally. Like you have to fetch that data and then operate on that data entity to determine if that entity is accessible or not, which is way too much work with the GraphQL layer. It seems better like to push that work into the gRPC service or the REST service itself. So I think so far, like what we've been seeing is the most convenient cut is that the authorization policy for what entity is accessible or not is just kind of pushed into the service itself, like the gRPC or the REST or the SOAP service that's servicing the model. It's been hard to do that at the GraphQL layer. Anything that's not like field level security, meaning this field is visible or not, right, has been hard. That's been the impression that I've had. Would love to hear from other folks on if there's any interesting GraphQL authorization stuff that's been happening for services.
I'm curious, Joey, when you say like you have existing REST and gRPC services, and now this is GraphQL, are you talking about like offering alongside REST and gRPC a GraphQL API, or like moving towards a GraphQL API? Is that what you're talking about?
No, I just talk, a lot of Tom-I's talks are like, you know, you can, I think I'm more familiar with AppSync because I haven't used Hasura yet. Sorry, Tom-I, but I would like to. But basically, yeah, you develop your schema, I think, and your models or your rules go with the databases, but there's a much more clean like paradigm there. It's just like my data and my fetching layer essentially, and it's easier to work with that way. But if you just have like, you know, a bunch of REST services that have been here for 20 years or gRPC or whatever, and now you're saying, hey, I want this to be in a graph so you can have unified access. How do you translate that stuff? Like, what are people doing? Like right now, I'll just say it so you guys know, we're using really simple auth policy directives that go on objects or fields, right? Objects just cascade, really, really simple stuff, but they don't do anything very complicated right now. They just, I mean, we have the concept of scopes and application context permissions between different apps and whether or not you're logged in, but it's not like, I don't know, we don't do a lot of like role-based, like cascading roles and stuff like that.
Yeah, I think things like scopes and things related to APIs in general make a lot of sense as like annotations on types. And I think what Tanmay said is key, like the fetching users or comments users should result in the same like authorization results. And if you're doing per like field level authorization only, you're going to make a mistake eventually. And I think that's why maybe like people say sometimes like, hey, GraphQL is super hard to protect because you can like access types from different places. But I think if you concentrate your efforts on protecting types rather than fields and use field like security as an exception, that secures you a lot from this. But what I'm curious about is authorizations I don't know, a user cannot add a comment to this pull request because it's not part of the team that created the pull request, like complex rules like these. And they usually make more sense. I'm of the opinion they make more sense, like deeper in your domain logic or your service layers. But one thing I'm really curious about is that it's kind of intention of your domain layer being user aware, or viewer aware, should I say. So, and in my experience, I've rarely seen code that's already set up this way, where every function that exists in your domain accepts kind of a viewer ID. And so it's really nice to be able to push that authorization logic deeper, but often the existing APIs of a big code base, I've noticed, don't necessarily support these viewer aware APIs. So I'm curious if anyone has been successful pushing that deeper into their stack, or you're more doing like resolver level authorization checks.
So previous company, we were able to solve this pretty well. And this was back in 2018, so still pretty early GraphQL days. But what we did is, because you have the context available at every resolver level, we had an additional, we called it a data filtering object, but just another entity we kind of put in between the end result of the resolver and the data fetch layer. And everything had to pipe through there. And so we were able to do all of our user role-based filtering at that level. And in the case of fields, we were also able to handle some of that behavior. So it would strip out anything that your user role didn't have access to, as well as handling general, like you don't have access to this entire entity object. It's the cleanest approach I've seen so far, and I've continued to adopt it on future projects as a result. But it's one of, I'm sure, many options that are out there.
For that one, are you declaring then the sort of restrictions in the schema, or is this in the resolver that's doing the filtering and validation?
So we actually separated out the logic a little further. So the resolvers relied on a business logic layer case, and that business logic layer accepted the entity scope. And this was also true in the previous iteration, which was a REST API. So it was already kind of baked into the entire system, and we were able to just translate it. It's like, hey, here's the same user. We had to change how the context was read from, just because the REST implementation and the GraphQL implementation were ever so slightly different. But that small difference, it was just handled at the business logic layer though. And so then all resolvers benefited from that abstraction layer, which was, I think, really helpful in the overall migration. But then I've seen other systems where that wasn't inherently baked in. And so we had to add another layer on top of a business logic layer strictly for authorization. And I think that's where it gets messy. So it kind of like what Mark said, if it's not inherently baked into a system already, it's exponentially harder to implement later, but worth doing in my opinion.
Yeah, the reason I asked, we went down a rabbit hole of attempting to declare these things in the GraphQL schema. I think it was an interesting thought process because it's useful to be able to map those, say, authorization errors to domain things, or just be able to see it in one place. But it definitely got a little hairy. But yeah, it was under the hood applying something similar to what you're talking about in terms of different role checks and things like that based on the context. But I'm not sure if it was worth the extra work versus just skipping it and going straight to the resolver.
Yeah, I think, I mean, Tenma kind of alluded to this, but trying to keep that logic out of the resolver, I think, is worth it, because you don't want to overload the responsibility necessarily. Like I've seen some resolver schemas get out of control. I mean, we're talking one model and it's already a 4,000, 5,000 line file of resolvers and their functionality because abstraction got a little crazy. That's just been my experience though. I think although a lot of new patterns are kind of against adding more modular layers to things, I think it's really important to still do that as the ecosystem grows, especially in a large enterprise application.
Yeah, definitely, that makes sense.
One like stuff that we started like thinking about was, I'm with the same opinion that like it's always good to push it into the domain layer, because there's like knowledge of, I think authorization always tied to the business logic, and it's much easier to manage it there. The knowledge is there, but what we tried to think of was like, even though you're doing that, could you still, let's say, take that logic that is being written by the people who know, those rules the best, but then also use that logic inside the GraphQL execution, so you could fail early, for example. We have some new things there. Like recently, we also like the Matik, the guy who wrote GraphQL Shield, joined the guild, and then we got actually another group that worked on a new library that's called GraphQL Auth, and we're going to publish their blog post soon. We're thinking that might give. We'll still. I don't know. Like, there's still. It's a question there. Like, what's the best approach? I think but I think it might be cool if we could kind of like enjoy both having the logic somewhere close to the business logic, but then still fail early at the gateway. So yeah, maybe I'll share later, like a blog post might be related to that.
This library is pretty cool. It's very similar to an approach that we were doing around being able to declare all of these rules and how to combine them and stuff like that. Do you know if the types themselves get changed as a result of using these directives, like the code generated type?
It's a good question. I think the type, we haven't looked into that yet, but it's a really good question. It's worth looking.
That's kind of what we've been doing, John, in the sense that like the types do change, but it's we call it scope-based schemas or role-based schemas. So the idea is that for a particular application scope, you're going to get a schema, but the name of like the user type that you get for a scope called user and the user type that you get for a scope called something else, right? Like manager or admin. It might be called the user type, but it might be different, but it's tied to a particular scope. And so the assumption is that any application or any client is using the API as a scope, right? Within a particular app scope, right? So they're getting kind of the types that are code gen for what their types should be, right? This fits in like well with the schema visibility part of the authorization discussion, right? But not necessarily with the authorization part of like what data entities can you access and what data entities can you operate on. That part is still like closer to the like deeper in the layer, basically, right? It's closest to the model because I mean, it just needs to be there, I guess. But yeah, I think schema visibility has been the only thing that's been tractable to specify at the outerish GraphQL layer, right? And it still feels okay. As soon as we try to think about like putting in more authorization rules at a GraphQL schema level, but not at like a model level, right? Even resolver level is too detailed. And GraphQL level is far too detailed. Like it's too verbose. It's like it becomes too much. So schema visibility has been easier, but anything more than that has not been nice to put on the authorization side.
In practice, I'm curious about folks have done the sort of mass, like gigantic monolithic graph and then cut out those, what you're talking about, the subset graphs related to the role and executed things against that. Is it, I guess that's what you're talking about, Tamai?
Yeah, that's what I was mentioning. I think Joey was mentioning last time that they've been doing something similar, right? They've been trying out like this schema visibility thing. Joey, have you folks been implementing that? How's that been going?
Sorry, about what exactly?
Like basically the idea that like you have subsets of the schema that are visible to certain scopes. Like you don't get to see the entire graph depending on the role or the scope or that you are in. Like,
yeah, I mean, there's a couple of things going on there. There was our concept of like BFFs on the graph. That's a whole migration strategy, like something completely different. And for that, those chunks of graphs are definitely locked down to a particular client through a scope and that auth policy director I was talking about. And then there's the visibility portion of it, which is essentially going to be using Apollo contracts. So you have to authenticate before you can even make a request to the graph. So we require a bearer token. And based on that authentication, we understand who you are and we understand which graph you should be seeing. So we'll essentially send you a copy of the graph that we want you to see based on tags. So we'll tag our graph up and say like, this is the merchant graph or this belongs to this. And we'll assign tags to groups of people. This is vaporware right now as I speak. So that's what we are hoping will happen once all of the contract work is done. And I just want to throw in there that I like this introspection topic. I know it gets crazy. I don't know. My gut feeling is that introspection shouldn't be a security issue because, you know, these are queries that that's like your API. That's like saying, you can't see this REST route. It's like, no, people know the REST route exists. You just can't access it, right? So I don't know. I'm kind of that manner. And if you have these contracts and you basically say like, I know who you are and I'm only giving you a graph that you can access, then what's the harm in letting them introspect that? Because that's something that only they can play with anyways. So for sure, like we don't have introspection turned on because our security team freaks out and says, this is the rule. We read it on a blog. And for me, I'm just like, okay, well, that's great. But if you change this one sentence of, it enables the hacker to, I had a really nice snippet. Basically, they wrote a sentence that said, this allows the hacker to see all of the schema and do some malicious things. I said, replace hacker with developer and malicious with, you know, like I forgot, but the sentence read really well. Like this provides the developer a way to see your schema and use it completely. So, yeah.
Yeah, makes sense. but I think it depends on like how mature the security side of like the tooling is, right? Like if like you have like really good like things in place to let people like, suppose if you have like, for example, like good persistent queries and allow listing in place, right? Then it doesn't matter. Like, go take my schema, party with it. Like, who cares, right? Ultimately, you're not going to do anything because I'm not going to let you do anything in production, right? So yeah, so there's
like everything in GraphQL, it's very contextual. What are you doing? What's your setup? Are you a public API? Are you not a public API? You know, everything matters. Are you generating schema from your database and not really thinking about it too hard? Like, yeah, I would say everything goes into whether or not you should allow introspection.
Yeah.
But I don't think a blanket statement of just turn it off in production. I just don't like that. That's not sitting well with me.
Kind of defeats the purpose of like this whole idea of having like a schema.
It just seems like a really powerful thing that if you did it right, it can be awesome and people can just playground onto your stuff. Yeah, I know you can avoid having playground, but that's not the point.
Yeah, makes sense.
Well, I think what we're going to do is take a quick 5-minute bio break, give people a chance. I know we go for a while, and give everybody an opportunity to get a coffee. And
then I think immediately after that we can dive into favorite topics of the day. Always the everything related to microservices, federation. What's the updates there? What is the wish list there? We've been kind of touching upon some of those topics already there, but it would be useful to kind of get an update and like just update in thoughts also from folks around the table. So I think maybe we can touch on that right after a coffee/bio break.
Yeah, we'll return in about 5 minutes.
You guys need some of that Apollo Summit music.
Yeah, we've it's like, I think it's going to be like a feature that Zoom adds soon. Like whenever you're in a waiting room or in like a breakout room, they'll have like a little thing that lets you at like some chill house, whatever the genre. Whatever.
I'm always dancing in those summit breaks.
Yeah.
Elevator music.
I don't know if you've used Slack huddles yet, but if you're the only one, it starts doing that.
Yep.
I thought my Spotify went off quite a number of times. I was like, what's happening? And then I realized it was Slack being Slack. And then it muted me, and then I was really upset.
I use huddles, but I don't go in there by myself, so that never triggered.
I get in there, and then if somebody doesn't join with like 30 seconds, 45 seconds of you joining, they turn on the elevator music and auto mute you. It's an interesting feature.
Yeah, on the particularly dark days, you can just start a huddle with yourself and then just, listen to the music as it comes.
Those are my Mondays, so Monday will be my self-huddle days. I'll call them office hours, and no one will come.
Actually really great, because then you can put it on your calendar, and Joey's working. He has so many office hours these days.
You guys don't know how truly weird I am. At one time I had a meeting and it was all dark in the room. People came in and there was like whale sounds playing, like, and I was just like, guys, welcome to the meeting. I was Scrum Master at the time. They don't let me be Scrum Master anymore.
At that one time, Joey did it, and that was it. Well, I think we're gonna pick back up. It's been about 5 minutes, maybe a little longer. Give people a minute. Wanted to shift now into the amazing world of federation and microservices and all the things that GraphQL can do in that area. I don't know if Roy's back yet, but I know he particularly had a topic surrounding this. But if not, does anybody have any? Oh, there he is. Sorry, I didn't mean to rush you back.
Okay.
So Roy sent a question in earlier, or wanted to talk about federation being supported by GraphQL servers to make it possible out of the box. Is that generally the topic?
Well, something I wanted to know about was federation, how people are doing it. I mean, it's StepSim, we have an approach, Apollo has an approach. I believe Hasura also has an approach. So I was also thinking GraphQL Mesh can do some sort of federation, bring services together. So I was also thinking, like, should it be like a default way to do federation? And generally, what people are using.
I think the approach that we've been recently trying out that, so we do it at two levels, right? One is kind of the service to service federation, and one is kind of the more data source to data source federation, right? It's like I have two different data sources and they have like physical models or logical models, right? Like, and I want to combine across them. And so we use a slightly different execution mechanism for that. But like the way it works is that you bring in data source one, you bring in data source two, you specify like a logical model on data source one, you specify a logical model on data source two. And the logical models might come from like 5 different tables or like have some computed fields or whatever, right? And then you say that there's a relationship or a join condition that you specify as a part of the GraphQL server's configuration. And then Hasura is able to take a GraphQL query and create the right query plan and do like temporary tables and predicate push down, like do a bunch of things that makes that cross-domain, cross-data join very effective. When we do like the service to service stuff, the GraphQL to GraphQL stuff, we follow a similar kind of semantic model where at the GraphQL server's configuration, you configure saying that type 1 from this GraphQL service and type 2 from this GraphQL service have a connection. So then all the resolvers get auto-updated and stuff, right? Like that just happens. This is not very efficient, like as efficient as possible from a query perspective because we don't control the data sources. But it's pretty much, I think, the best that you can do, like with good query planning and data loading and like memoizing and like all of the usual techniques. but the specification of like what you're joining type things is done at the GraphQL server configuration level. So that's the difference that so far seems to be interesting for us. Like we haven't expected that the services will publish the joins, like the relationships, if you know what I mean. Like service 1 says I'm related to service 2, service 2 says I'm related to service 1. That relationship is not happening at the service level, it's happening at the GraphQL server level, if I'm making sense. But that's been like how we've been thinking about it so far. Would love to hear kind of how that's evolved for other folks.
Yeah, makes sense. Yeah, what I dislike of some implementations is that underlying services need to be ready for federation. Well, I would be saying like it's really nice if every schema can be federated with any schema on the planet, basically.
Exactly right. But then I think you'd have to do that configuration at the entry point, right? At the GraphQL entry point rather than at the service.
Yeah, so you would say this is my server. There are tons of other services, and from my server I connect other things.
Exactly. Yeah. Something.
They would always have schema A and B that you want to connect through schema C.
Yeah. That's sort of sounds like. But I'm just gonna pick on like Mark and Joey again because I think they've been doing some like interesting microservices federation stuff, right? Like what has that been like, folks? In terms of kind of where the like asking the service owners to publish the relationships and stuff like that, like how has that evolved, and like what are your thoughts there?
I don't want to go after Mark again, so I'm just going to jump in. We do Apollo federation, and right now we are not federating anything. So our router is our gateway is a glorified router, but we have our first use case where we've got, two graphs that want to play with each other. So that's exciting. I will say that as far as like coming together on like a unified federation spec, that would be great. But let's keep fighting it out, because even within Apollo, they've now switched from Federation 1 to Federation 2, which solved a bunch of problems that we didn't like about the first one. So I think there's a lot of iteration that needs to happen here. So like, yeah, let's all keep duking it out in our own corners or whatever. But I'll have more when we start doing it. Right now, federation is still kind of this like concept that we're like, it's going to happen soon.
Got it.
I just want to say Joey has been overly humble here, having seen a few things they've been working on, a few sneak peeks. Yeah, they're working on pretty amazing things. So, and I think actually we're working on pretty similar things. So, as some of you may know, I was once pretty critical of federation, or at least careful of federation, especially for people starting from a monolithic architecture, not going to GraphQL for federation, but using federation if you are in a microservice context in the first place. I think is beautiful if you have the observability for it and the tooling for it. So yeah, Netflix uses federation. It is based on Apollo federation spec. The difference is we do have our own gateway built in Kotlin, but it is fairly standard Apollo federation. Yeah, I'm not sure what else to talk about, but it's been working pretty great, especially with the observability stuff I talked a bit earlier.
Oh, I will mention one related thing. We did something, I guess, cool, which was there's a problem with Federation 1 in that I don't know if this happens in any of the other implementations of Federation, but if you try to like have two different value types or two different enums that are different from each other, it like blows up. And what that means is that if you have to change an enum, for example, and you have maybe 50 subgraphs, you have to change that enum in all 50 subgraphs if it's present. They call it schema shuffling, right? So you got to do this lockstep thing, or it just seems like it sucks. Federation 2 is supposed to solve that. I'm not going to like pitch that right now, but in Federation 1, the way we solved that was we added a subgraph registry. I used a lot of what I like to call guerrilla warfare. There's not a ton of resources on my team, so I just do things that I think can get done. One of those things is not pretty, but I just threw a GitHub repo on top of Apollo Studio. So effectively, the way that you manage your subgraph registry, where all your subgraphs are and what routes they're on and what schemas they're responsible for, is that I took away all controls from the rover command line that Apollo gives you. Nobody can use that for this particular graph. Only the CI can do it that's in the GitHub repo. You just make PRs, and as you make a PR, it'll do a check. In that PR, you can affect multiple subgraphs. So I can make a PR that updates the enum in all 50 subgraphs and that kind of thing. So schema shuffling is not a problem if you have a layer in front of it. So yeah, that's pretty cool.
Joe, in
and also you can revert things. That's another big deal. We can revert changes and see who did things.
Joe, does that mean you have a monorepo for the schemas for the subgraphs, even though the services are not in that same repo?
Absolutely, yeah. There's just a GitHub repo. It's called subgraph registry. It doesn't do anything except for have a config of the subgraphs and then the actual schema files referenced. Yeah, we also build in some notification system there, and yeah, it's cool though.
How have you maybe solved some of the front-end consumption through things like we use Cogen a lot, and how have you kind of solved that particular problem with some of the spiraling effects of federation, as you kind of mentioned?
Sorry, that's a question for me. Like, how do we generate queries for clients based on our?
Yeah, or like, as the idea of federation is we have the single point for anybody to consume our GraphQL API, and it stitches everything together for us. At least that's my understanding of federation. And I'm simplifying because I know we have some people in the audience who aren't following as well. But how do you provide that to the client consumers? Do you just say, hey, the front-facing federated graph that you've produced is now your source of truth, or do you let people cogen from all of the different microservices?
Yeah, no, they have consumers have no concept of federation, right? It's just this is api.paypal.com/GraphQL. That's the graph. For all intents and purposes, they have no clue what's going on underneath. So they'll take that super graph schema and do what you normally do with a graph. So essentially, at that point, they don't know.
That makes sense. And then I know we were talking about joins, and I forgot whose opinion it was, but joins should exist in the kind of super layer, so to speak. How, with like enums being maybe a layer down in some cases, how would you handle that? Like, has anybody experienced that? General question out there.
How do you mean exactly?
So
like,
I mean,
the question, just to add to that, or like maybe paraphrase that, right? I think like where do the dependencies or the relationships between types go? Do the services publish that themselves, or does that happen at the central GraphQL layer? Like, what has worked and what has been better? And I think like Mark, given that you've been kind of using that with the federation style, I think would love to hear your thoughts. And then Uri, of course, has been doing a bunch of work in this space. Also, would love to hear from like how that organization of where these relationships exist go. Or does it not matter because everything is in a mono schema repo, right? For what Joey was saying, like there's a mono repo that has the whole schema, so it doesn't matter like where the relationship is written down or expressed.
So for us, most things are in their own service, so there's no mono repo, and they register themselves to a schema registry. That usually happens during a build step. CI, we have tooling to register against. That registry validates a lot of things. It can lint, it makes sure it will compose as one big graph correctly. It'll do everything basically that you're sure that it's going to work when a client queries a super graph. And where these dependencies are defined, we're using the Apollo Federation spec. So it's implicit in some ways. I think with the next Federation 2, you can share types without necessarily explicitly say like, hey, this is a dependency. You're kind of like all working together, but there's also using directives to kind of instruct the gateway about those dependencies and making sure the gateway is able to build a query plan. But that's kind of the beauty of federation, is where you don't need to be overly explicit about all the dependencies, and you trust that the gateway has enough metadata about the subgraphs to compose them and being able to build query plans. And magic is in that query plan, right? Like like databases. That's future federation is like building the best query plans we can, which is a very complex subject.
Yep.
Actually, I mean, we talked about this subject a lot here, but one thing that I was always interested in, I don't know if you could share it here, but like I was always interested in Facebook's implementation. Like, you know, like if we're talking about GraphQL at scale and, you know, handling crazy amounts of like huge GraphQL schemas and with crazy performance, I don't know if there's, you know, something that it can come close to this. And I wonder, you know, how they are doing it. Yeah, I don't know if you could share or not, Lee.
Yeah, I can talk about that. And hey, thanks for having me here. I joined a little bit late. My name is Lee. I'm a co-creator of GraphQL and the director of the GraphQL Foundation. And spent a long time at Facebook, of course, where I first started GraphQL with a couple other of my colleagues. I'm hearing all this conversation about Foundation, and Marc-Andre mentioned that he used to be kind of cautious about Foundation, or maybe even to the point of not recommending it. I'm still there for what it's worth. I think Federation brings a ton of value, but at a lot of cost. And schema registries, query plans, like there's just a lot of additional stuff that you have to manage. Facebook doesn't have to manage any of that. They don't use Federation. Instead, they use a model that we're actually now exploring at Robinhood as well, which is you have a single definition of your schema that exists at your gateway. Facebook's architecture is a little bit different from what we would consider sort of like a modern API architecture. They have their quote monolith, but really their monolith is a stateless gateway. It's just capable of doing a lot more compute. They do server-side rendering there in addition to API processing, but that's basically what it is. All of the definition of GraphQL, all of the schema, all of everything that a stateless tier with localized caching, so that when you need to load any data, what happens is you load out to any subservice that might own that data and cache it locally in the case that you need to touch it more than one time. That's where the data loader pattern came from, was managing exactly that kind of access model. I think the modern version today is probably best exemplified by what Twitter has built, which is using some kind of modern communication model between services and then leveraging that to build out your GraphQL model. So I'm pretty sure Twitter uses gRPC. That's what we're exploring at Robinhood as well. Service to service communication always happens over gRPC. It's far more efficient, far more safe than GraphQL for server to server communication. I will continue not to recommend GraphQL for server to server communication and recommend gRPC in its place. But GraphQL is dramatically better for over the wire from your services and gateways down to your clients, and that's what it was designed for. So the architecture that is, I think, one step evolved from the Facebook architecture is Facebook uses Thrift internally, which is basically gRPC, but having some kind of gRPC for service to service, and then accumulate all of that together at your gateway tier, where you either manually or automatically define your GraphQL schema. That has a number of interesting properties. One is the source of truth of changes over time for your schema is source control. There's no like registry that you have to keep track of, or side logs, or anything like that, where you're trying to keep track of how each services have changed its data models and how that aggregates. There's no complexity there. Like the complexity is just git log. Like that's how you figure out what's changed over time. That is incredibly powerful when you mirror that with a monorepo. And even if you don't, even if you have sort of like a side-loaded module repo for your clients, in Facebook's case, they have a monorepo. At Robinhood, we've also moved to a monorepo. And that allows us to say, given this directory, which houses our API definitions, if anything in that directory changes, run the code generators. And it runs code generators for client-side consumption. And it's the exact same model that you might expect if you're familiar with gRPC, where you change your gRPC definition. And when you do that, you simultaneously change your producers and your consumers of the gRPC data. That's a super compelling model, and being able to leverage Git as your source of truth for change and triggers is really, really nice in terms of how it interoperates with a bunch of other ecosystem tools that sort of treat source control as the truth and don't need to know anything about GraphQL, let alone APIs or even web traffic. They just know about files on a computer changing, and that's a really nice sort of bottom layer proof. It also has this nice property where downstream services don't need to worry at all about API traffic. All they need to know about is their own sort of internal under the hood API contract. It's not about web APIs, but purely about like data in, data out to that service. And to the degree that gRPC is a good model for that, there are others, of course. Then you can have service-to-service communication outside of the gateway as well. So this is another thing that we've explored multiple paths for. And what I think is interesting is both paths end up being valuable. This was true at Facebook. I'm finding it true at Robinhood as well. One path being direct service-to-service communication. You have service A, service B, and a gateway that ties them together with GraphQL. Service A might need to talk directly to service B, and it wants to do that directly over gRPC. That's completely valid. Or you have A or B or service C that needs to talk to A or B or some combination of the two, and it actually wants to consume that through GraphQL. And so having a path where hopefully where it doesn't need to sort of like exit your VPN and pop back into it again, but you can sort of talk directly to the gateway and then say, hey, gateway, actually have this complicated query that's GraphQL based, and I would like to load this larger amount of information. I'm willing to pay the minor GraphQL overhead in order to do that, is also super useful. When you're not entirely sure what service a particular piece of data comes from, nor do you care, and you want to buy that that abstraction layer in place where, you know, if service A migrates to service B, service C never even needs to know about that because it only ever went through the gateway in the first place, and that remains super valuable. So that's I think the evolution of Facebook's architecture, which is monolith. All GraphQL definition happens at that monolith, which is some combination of automatically generated queries plus schema plus a little bit of manually generated schema, which is layered directly on top of, in Facebook's case, Thrift, which has a programming model interface on top of it, or gRPC.
Lee, just a quick question there in terms of like how this is organized, because in terms of like the developer who's working on a feature for the API, right? Do you expect other teams kind of getting neatly isolated that like I have the service A team, which is publishing in Thrift or gRPC, and then I have a GraphQL team, which maintains the GraphQL API contracts, and how the mapping is done from the GraphQL schema into what services are being called is actually consciously maintained by a bunch of humans, right, at the GraphQL layer? Or is that piece also automated, or is the same developer kind of working also on service A and then also doing a little bit of their work to help bring it into the overall GraphQL schema? Like what combination works well?
That's a great question. And the answer is it's actually a little bit of all, depending on what your intent is and what you can get away with in terms of automation. So there's a lot of stuff you can get away with automation where you describe, say you want to, anything that happens over this gRPC goes over GraphQL, you just describe how you translate gRPC to GraphQL, and then any change downstream to GraphQL or to gRPC, as soon as you change the gRPC definition, you change the consumer. By changing the consumer, you also change the GraphQL interface. And you have to be intentional, like there's code review, right? Like you can see what the producers and consumers look like when you do that change. So your unit tests run and everything like that, but you're not writing additional manual GraphQL specific code. You just, in the same way that if you change an upstream thing and you automatically ran your code generators to change, say like Swift, like type definitions, you wouldn't want an API author to go write iOS code, but you would like for their changes to have downstream effects that you could automate if you want, and you'd want to run unit tests. So I think that's the base. But then there's this this understanding that there's a meaningful difference between a service's capabilities and what surface area of that set of capabilities you want to expose over your API. And you either need to get into the business of writing sort of allow lists and block lists on the fields in your gRPC fields, and then trusting that those will hold over time, Or you might actually want to have some derivation between, gRPC prefers communicating in this structure, but in GraphQL you want to use something else. Maybe in gRPC you have something string-based, but you actually want to hard-code it as an enum when it gets the gateway, or vice versa. Maybe it's an enum at the gRPC layer, but actually you expect that enum to evolve quite a lot and you don't want to churn clients, and it's actually more ergonomic to describe that as a string. Or maybe there's some other kind of derived data in place. Whatever it is, there's some intentional designed piece to the GraphQL layer. So in terms of the operating model, what this looks like, in a monorepo, this is a lot less painful because it's all one code base. And really what you're talking about is directory A for your service versus directory GraphQL for your gateway. And all of your developers just kind of know where the code lives, and it's not a big deal. If your code is developed across multiple repositories, then it's certainly a little bit of extra weight because every developer needs to also have the GraphQL gateway sort of checked out so they can, like, first I do my service change and then I go to the GraphQL and I also add some capability there, which could require 2 commits. Where in a monorepo it might just be 1. But then it's an intentional choice where that last piece is shared. So in both Facebook's case and at my team at Robinhood, we have a team that owns that. So it's not a community owned thing. There's a team that owns it. And that team is accountable for the health of the GraphQL service itself. If there are new common API definitions, so if there's like a generalized enum that gets used across the whole surface area, they might own those things. General patterns, logging, visibility, all of those kind of concerns would be owned by a single team. But then there's an open contribution model where, okay, we own the GraphQL service, but then there's, a subdirectory or a sub piece of the schema that's very clearly about this one vertical of the business or product. And like, clearly that is owned by some other team. They come in and they contribute to that over time. And that I found was a very viable working model at Facebook. It's well aligned to Facebook's culture, which is if you need to get something done, you just figure out what directory the code lives in to do that, and then you just get it done. Robinhood actually has a very diametrically opposed culture where there's a strong sense of ownership, and every single service is well owned, and every piece of code is well owned by a particular set of humans. But even in that model, I found that it works quite well because you still, even though you have the top level is clearly owned by our API team, and then like each piece below it is clearly owned by the teams who contributed that piece of schema. But it's true that then you end up with one service that has a large amount of people contributing to it. But I found that as long as you have good tooling in place, that tends to work pretty well.
Question for you, Lee. Is that layer? I'm curious about the resolvers. So you've got this gRPC layer. I guess there's a fair amount of standards that maybe you want to follow for being able to code gen the schema that accesses those. But are you writing resolvers as like directives or something, or is there actual code that's running at the GraphQL layer that's then calling the gRPC layer?
It's all code based. So in neither my old Facebook team nor the team at Robinhood do they write the schema using the schema definition language. They write it in code, which has the benefits of having the full power of the programming language at your heels. Facebook, of course, used Hack. At Robinhood, we use Python. Both languages have the ability to do annotations, which is a hugely valuable tool, which gives you a similar kind of expressiveness as directives, especially if you want to leverage code generation. So, for example, our Python type definitions read structurally very similar to a schema definition, and where you have, class whatever, which is the name of the type you're describing, a bunch of fields that are essentially stubs for the resolver functions, and then decorators that describe how that ties to some piece of auto-generated architecture. And then like you run some code gen and then it fills in the blanks for you and you're good. But you don't have to. If you take that decorator off, then you can just write a regular function, and that function can do derived logic, it can do something else, whatever you want. And then that way, as people are writing the code, they can kind of choose like what elements are going to be automatically generated. We can do that entirely where I just say like this type is generated by that gRPC definition, and then it's done. Or I can expand that out and do it on a per field. I can expand it out even further and go all the way down to writing resolver code. At which point there's another abstraction in place, which is you kind of don't want to write directly against a gRPC consumer, those tend to be kind of low level and fiddly to work with. You want to have a little bit of a layer between the two, especially if you want to do localized caching and or like put data loader in place. And rather than directly writing data loaders as part of resolvers, we tend to auto-generate those as part of our gRPC consumers.
So everyone has to learn. Everyone has to learn a shared language to be able to contribute on this graph. There's no polyglot ecosystem in this model, right?
Yes, there's like the one language of truth.
Gotcha.
For us, that's Python plus some MyPy types, which has been interesting. We actually had a prototype version of this before that was built in Kotlin, which I think Kotlin is an awesome language. I'm grumpy that we didn't go with Kotlin, but the rest of our company uses Python, and so that's what we want. Or most, we have a bunch of Go and Rust and other things too. But yeah, it does require that you end up with one coded service with a language that you expect the vast majority of your teams to be able to contribute to.
Would you then recommend for ecosystems that have to be polyglot, like PayPal's never going to say that you have to choose a language, you know, it's Java or Node right now. Would you recommend then, I'm just curious, federation for those companies, or do you think there's even still a better solution than that?
Well, to be clear, I'm not saying that federation is a non-viable or bad. Like clearly all of y'all are using, or many of you are using it and finding a ton of value from it. So that's great. I'm describing an alternate model here, which is you know, the GraphQL all lives at the gateway, and it's designed rather than generated from federation. But you might choose federation for a bunch of reasons, and I think that could be one. Maybe it wouldn't be the top of my list. I think like disparate organizational structure might be the primary one, especially if you, I think, especially for Intuit. Intuit has a lot of business wings that basically never talk to each other. So it's not even about whether the languages are similar, but like, is there good communication streams across everybody who contributes to that schema together? Maybe that's the reason, and you really want to give autonomy to each of those teams. At Facebook, team autonomy was an anti-pattern. Our culture expressly did not like that, because we wanted to build the organization that recognized that the product surface was one thing perceived by a customer. So we wanted to treat it that way on the software level. At Robinhood, we're a little bit in between. You know, we of course have pushed things towards a monorepo. We have a strong ownership model, but there's still a sense that teams need to interoperate together in order to get something holistic done. But if you really value team autonomy, then I think federation is a fantastic tool to manage that. For polyglot environments, I can see it going multiple ways. I have high expectations of engineers. I expect a good engineer can learn multiple languages. So the idea that like, hey, my gateway is written in Kotlin, but like all of my engineers are Java, it's like, get them to learn Kotlin, you know. And it's like, if they really like that ends up being a brick wall, and you're like, I can't convince the folks across the company to agree to contribute code in any one particular language, then sure, federation can be a way out. But I don't know, that makes me a little bit grumpy, a little bit sad that the reason you would go to federation is you can't teach your engineers new things or can't get them to learn a new thing, as opposed to a lot of the other, I think, like much more valuable reasons that you would choose federation.
Yeah, I want to talk about this a bit, if you don't mind. I think, like, from our perspective, from the GraphQL community's perspective, we often like only see GraphQL itself and kind of ignore the underlying concerns. But when it comes to like big companies, like we talk about Facebook, Netflix, there is a ton of work that went into the culture, the organization structure, the tooling, how they operate already. That makes a huge difference. Like, I wouldn't go work at Facebook tomorrow and be like, you know what, teams need to be more independent. They need to be able to use their own language, and we're going to use federation. Like, or at least I would need to have a very, very, very good reason to propose that. Same thing that I wouldn't go to Netflix and be like, you have all these services, that's over. We're going to build this one big monolith, and everybody's going to contribute to the schema there. So I think we often forget about that in conversations. Like, GraphQL is often not that huge of a deal compared to everything that's been built, like forking the language, making sure a monolith is able to work, making sure your source control system is able to work at that scale. Like, there's a huge amount of work that's unrelated to GraphQL that you can't just like change like this. So yeah.
Love that point. And it reminds me of Conway's law, right? Your organization tends to produce software that's shaped like that organization. And I think Conway's law is written in terms of a like non-designed or an unintentional result. It's like you intentionally design your organization structure, and then like, whoopsie, like your software now looks like your organization structure. But I think like if you understand Conway's law, then you can leverage it as a tool. So it basically says like the river flows this way, and you can swim downstream or you can swim upstream. And swimming upstream is really, really hard, and swimming downstream is like really easy. And a lot of times when we're talking about these architectural decisions, the net result is actually like very similar, right? Like Joey, to your point earlier, clients don't see any of this. Like they just see yourcompany.com/API/GraphQL or wherever you host this thing, and like check it out. They get a holistic API. That's what our front end developers want in the first place. Like fantastic. However it is that we arrive at that conclusion, it doesn't matter that much. And so we should choose the one that is swimming downstream for your organization rather than swimming upstream. So if your organization is structured in a way that truly values autonomy, values polyglot environment, then like pushing everyone to like force them to contribute to a shared monorepo where your API definitions look like, that's going upstream. Like it's not going to work. But like similarly, so if the team really values interoperation between teams and high touch on the API surface layer, and like strong connection bonds between individual service teams and the front end engineers that consume them, then federation just feels like extra stuff to work around and would be pushed back against. And you can sense my bias. I tend to gravitate towards teams with the culture of the latter, but I absolutely appreciate that that's not the thing that we see everywhere. I love that point, Marc-Andre.
I do want to call out also, one of the pain points we're having with federation, since we're using it, is that you can federate like technically, but if you don't federate from a point of view of like how you approach the schema, so schema design review process, if that's not federated properly, you're in trouble. And we're experiencing some of this pain right now. Like, great, technically federation is solved, everyone can be their own stack and whatever, like let's all join the same graph. But the moment you start to join the same graph, there needs to be some sort of federated review process. And that's kind of like what we're trying to wade through right now, is like, how do we do this so that it's not just the Wild West and people are doing whatever they want, and then that doesn't turn out that great. So that's our greatest challenge right now with federation.
I have an interesting story here as well, which I know Facebook is unique in many cases, but this might actually parallel the experience many people will go through. You're in an organization, you already have services running, you already have a product, and you're trying to figure out, how will I introduce GraphQL? So you get organization buy-in, people are like, GraphQL seems really cool. Okay, now like, how do you approach this problem that Joey just described, where, okay, everyone's kind of into it, but they might not know how a well-designed GraphQL API might look like, and you want to make sure that what you end up with is high quality. So what we did is we started with a very small set of folks, essentially the people who built GraphQL, and we designed, I think, Newsfeed at the time's API and a pretty small surface area. And we basically said every new thing that's going to come into this is going to have to go through us. We were going to, heavy design review process. And we did that for a while, basically to make sure that, if you needed to represent a date, that we ended up with like 5 different ways to represent dates. Like we push it towards one. And we eventually sort of built a library of case law and precedents, and we could point to stuff. And eventually we ended up with like a bunch of really good design principles that we liked. And also we had all these people who kept coming to us with, hey, I want to change this piece of the API. What do you think? And we also had these people from across the company that had gone on this journey with us. And so, if we're the Supreme Court of making API decisions, then these were the, the case lawyers. And at one point we said, okay, case lawyers, you're now the federal judiciary bench or whatever. You are now the folks who can take this settled case law and bring it back to your parts of the organization. And in that sense, we actually really did federate design review. We called it Friends of GraphQL, and these folks were the design reviewers for anyone in their part of the organization. So we had someone on the photos team and someone on the messages team, and so on and so forth for a bunch of these surface area. And as their groups kept working on GraphQL, they would try to make sure that locally they're making good design decisions. And if they weren't sure, they could always sort of bring it back up to us, and we would talk about particularly challenging things. And that ended up scaling well. There ended up being sort of 2 layers to that, where we had in each area, one person who was sort of the person who'd been around for a long time doing this, but then they would also sort of delegate out other sub pieces. So you'd have, someone within photos, and then another person who would own, specifically the albums part. I'm kind of making up this example, but you end up with this 2-layer thing that ends up with a large number of design reviewers that all sort of point back to the same set of case law, and there's a path for flagging issues and raising that to one group. So you still have one sort of authoritative group that can make tough calls about holistic design decisions, while still having a broad set of people who can help locally make good decisions. And then everyone there had the same set of working principles, knowing that, hey, we're empowered to make local decisions of what's right for our product, but at the same time, we appreciate all this comes together as one API, and a front-end engineer is going to see one API, and they're going to think weird if there's many. I don't think the end result was perfect, but the end result was very workable, and changes happened pretty quickly and didn't get blocked on our centralized team.
That's good to hear. That's what we're doing. We have domain architects, and we're building out a training process, because they're all REST architects now, but they're going to need to be GraphQL architects, and they're the ones that will sign off on their domains. So hopefully that'll work the same way.
Love it.
I have also a question, hypothetical question about, you said a bit about that you would recommend, let's say, gRPC for service to service. I wonder, part of the cool thing about GraphQL is that because the intent of the consumer, so in the query of the consumer, you could evolve the APIs faster or easierly, right? You don't need to make a breaking change, and you basically can say, okay, so this specific field hasn't been used for a while, but and in an endpoint you can't do that, right? You get the whole endpoint. I wonder if do you see that also being useful for service to service communication? And how could do you see some ways that we could get these benefits also over, let's say, gRPC, or I don't know, service to service communication in general?
That's a really good question. It reminds me, another thing that GraphQL gets you that gRPC does not is subselection. With gRPC, there's one shape of data, you get the whole thing, which for service to service communication is actually the right trade-off, because bandwidth tends not to be your bottleneck, it's compute, and subselecting costs compute, and having the same shape does not, and you get some caching benefits along the way. But your point here is a good one, that how do you know you can deprecate a field, but especially if generating the data for that deprecated field is costly, how do you know when the right time is to actually kill that off? gRPC has a model for this through their field deprecation strategy. Basically, you mark a field as deprecated in the definition itself, and then when you do producers, you produce a consumer which has that deprecation information flagged that says hey, the producer wants to get rid of this. You should be aware. Here's the migratory path. You can add comments there. In fact, GraphQL's deprecation function is largely inspired by gRPCs. That's where the inspiration for that came from. That's only half of what you're asking though. The other is well, what about stuff that, I don't know, it's you're not aggressively trying to deprecate it, but it would be nice to just kind of keep things tidy and clean if no one's ever consuming that in the first place. There, I think it's a little bit of a mixed bag, and it depends a lot on your source architecture. So with GraphQL, especially with a public GraphQL API, you have no idea what people are doing aside from your logs. So it's incredibly valuable to be able to break down each query and get a real sense of who's hitting what. Even if you do have strong source control and every consumer of your API is in your source control, especially if you're shipping mobile clients, you might have old clients in the wild, right? Shipped software, you can never take it back. And those folks might be still issuing queries for deprecated fields. And so having a real source of truth of who's querying what is super useful. For service to service, a slightly different set of problems exist. You tend not to have shipped software. You tend to have control over all of your consumers. Not always the case, but I'd say like 99% of the time, your gRPC consumers exist within your like service VPN, which means you can go look at source code. And the really nice thing about gRPC is it is entirely predicated on code generation. You write a gRPC file as a source of truth, and you code generate in both directions. And so you can then like do whatever you want with that. And so, you know, if I were being charged with like, hey, I want to go clean up, and I got a bunch of these old fields that are like kicking around in all my gRPC definitions, I want to figure out which ones I can go delete. I would add to my code generator logging on the consumption side. I would say like, okay, I produce this stuff and then I consume it, and by consuming, it's like a bunch of getters. And every time I hit a getter, I want to, you know, increment a value in a counter, and then I can essentially get the same result, but I'm doing it on the consumer side rather than on the producer side. The producer doesn't know, it's just yielding values, but the consumer does know, and that logging is where I would get that. There's a little bit of overhead there, but there's also a little bit of overhead for adding GraphQL field logging. So like, I think it just shifts it. So I think you can get that if you know where to put it, but yeah, it's a slightly different shape from GraphQL, that's for sure.
Yeah, I mean, I'm asking because one thing, so I thought about it a lot, and I never got like to discuss it with a lot of people. So it's really cool that you're here. And just like one thing that we experimented with and we're doing now is that we basically, let's say we have a bunch of services that are written in gRPC. So we generate SDKs for them, but then we actually also do the conversion to GraphQL on those SDKs. So then, like, you could actually, let's say you get an SDK where you could query GraphQL on the SDK on the consumer level. You log those, you both log those queries and convert them into gRPC. So then it's kind of like you could play around when you have also this option. You could like play around with the different like because it's those trade-offs, right? Like, because if you many people we started that because we saw a lot of people actually putting GraphQL on the provider level because of those benefits. But then, you know, like you said, caching is harder, and also the data manipulation work is being done on the provider, which is not necessarily the right architectural choice. Yeah, but also we weren't like, we did it and then we weren't really like super experts on gRPC. So maybe we thought like there's something like that already in gRPC, or we're just, I mean, we're doing something really weird here, or yeah, I don't know.
I think that's part of what I like about the gRPC ecosystem is that you can actually bend it to do a lot of things. It's if you can't tell, gRPC and a lot of the things like it were part of the inspiration for GraphQL. Thrift, Protobuf, Captain Proto. I'm a big fan of all those layers and borrowed many concepts for them for GraphQL.
Speaking of ideas that influence GraphQL, Lee, would you like to lead us through a little exploration of what's new with GraphQL, with the foundation, any foundation updates themselves?
Sure. Yeah, there's, I think, a handful of super interesting things happening right now. I'll start with foundation things, and then we can get to what's new and with the technical side of the foundation, because we have the two halves. Two interesting things happening on the foundation side. One is, as many of y'all know, we have a working group that contribute changes to the GraphQL spec itself. That's super healthy. That is a community-driven thing. So anyone who has an idea can show up to those working group meetings. They bring their proposal, they talk through them, they get advice and suggestions, they move their proposals along, and eventually we add them. And there's a bunch of very interesting and super powerful stuff in the works there. That group is overseen by our technical steering committee. And our technical steering committee was put in place about a year ago for the first time by me, which meant that I just picked a bunch of folks. The intent is for that technical steering committee to essentially run itself in the long run. I'm trying to get myself out of the business of handpicking these things and deciding things by myself. So we have an elections process going, and we had a bunch of people nominate themselves to be members of our technical steering committee. And that nomination process just closed about a week ago, and we're about to run a vote. So that's one thing I think is pretty interesting, especially for many of the folks here who are paying attention to the development of GraphQL itself. So that's one thing that's going on that's pretty cool. Another thing that is really awesome is, we started the GraphQL Foundation for many reasons. One of it was that we wanted to actively encourage community-driven development of the core of GraphQL. And one way we can do that is by financing it. And we have a bunch of members and sponsors of the GraphQL Foundation. We've built a modest budget, and now we're taking a very significant part of that budget and distributing it back out to the community via a grant program. So if you go to graphql.org today, and I think you scroll all the way down to the bottom, it's in the footer, but there's a link there that's called the Community Grant Program. I'm trying to remember the exact URL. If someone finds it, go ahead and post it in the chat. But you'll find there's, we just opened it up about a week ago for the first round of submissions. You can write about what it is you're going to do that'll help the GraphQL community and apply for one of these grants. We'll probably accept half dozen to a dozen per quarter. We're planning on running this every quarter, and each grant is going to be somewhere between $1,000 and $10,000. So nothing to shake a stick at, also not enough to live on. So don't quit your day job and go apply to GraphQL community grants, but hopefully meaningful enough to buy people's time to really invest in making the community better and the technical process better itself. So I'm super excited about those things. On the technical side, we just released a cut of the GraphQL spec. That's a fairly minor thing in terms of its impact on everyone who's using GraphQL, but this is actually a really valuable thing for the set of folks who contribute to this. It's a bookmark at the end of a very long chapter of the journey from GraphQL being a Facebook project to GraphQL being a community-owned project. Our previous spec cut was that's part of the reason why it took this long, is I now know way more about open source law than I care to, and we had to kind of run a process to make sure anyone who's ever contributed to the spec agrees to a new thing that basically says we're not going to sue each other for using GraphQL, which means this is actually really important. There's a bunch of companies out there that explicitly say that they can't use GraphQL because they have some concerns that at some point in the future they could be sued because some arbitrary contributor to GraphQL might decide to go do so. That can't be the case anymore. So that was one thing that we fixed. The contribution model itself was improved. The tool that we use to deploy the spec was improved. And then of course, there's been a ton of super fascinating changes to the spec itself. I wrote a blog post about this about a month ago that documented a bunch of the changes in there. There's numerous. But it was actually have even accelerated since then. I would say if you look at a handful of our recent working group meetings and just kind of pay attention to what's going on, you might get the sense that a lot of things are changing. And that's true. If you look at the spec cut and see like what's happened in the previous 2.5-ish years, more is happening now than happened in the previous 2.5 years. So I'm actually even more excited about what's coming next, which includes nullability operators, streaming results, input unions, and many other very significant changes. That's my stream of consciousness big update, but I'm happy to dig into stuff and talk about it and answer questions.
Quick clarification, was the title of that blog post GraphQL 2021?
That's the one.
Fantastic. I will share with the community.
Should do it the opposite of community grants where we can pay for certain things. Let's get those input unions.
I mean, that's actually kind of part of the intent of that. I know. So for those who don't pay close attention to the working group, Might be surprised to learn just how much work it is to make a change. We, some of the changes that have landed in the last year or so, were in process for multiple years. And our intent is not to make every change take multiple years, but it's not uncommon to take at least a few months, even for something that might seem like a small change, which for people who are familiar with contributing to open source software feels glacially slow, because they're used to, oh, I found something with an open source project I care about. I'll just write a pull request and send it in. Someone will go review my pull request and merge it, and the new major version will come out, and then I'll be able to use that thing. That might happen over the course of a few days or maybe even a few weeks, and it's not the speed that we use. If you compare that to, say, the PEP process for Python or the JavaScript ECMA RFCs, that's about the speed that we run at, right? Where those proposals show up, they get talked about for a really long time. We want to make sure every single change we add to GraphQL meets an extremely high bar for usefulness, for quality. Basically, anytime we start with the assumption that if you change GraphQL, you have produced cost. Every single person who uses GraphQL now needs to make sure their tools didn't break, that their existing schemas didn't break. If there's a new thing, they got to go teach all their colleagues that new thing. There's a lot of cost with even a very minor change, and we need to make sure that the value for such changes meets that cost at least, if not exceeds it, and ideally exceeds it. And that there's no like edge cases and corner cases where we go, oh, whoops, and then like we got to go change our mind and go fix that, or a patch release. Like we don't do patch releases. We get it right when we land it, and that takes time. And because it takes time, the people who are the champions for these changes spend a lot of time on this stuff. Luckily, there's a lot of companies out there. Big props to those companies who support their engineers for owning those changes. And so we have folks who show up who say that they use their company sponsored time to work on these things for 20 or 30% of their engineering hours, and they work with us in every monthly meeting over the course of an entire year, and then ship something, and that's fantastic. Others don't necessarily have the luxury of that, and they need to borrow time away from work, or maybe they do contracting or something like that, and they're literally borrowing potentially paid time away from themselves when they do that. And that's the intent of the contributors grant. We want to make sure that people who are really benefiting this community by building extremely powerful upgrades to the core of GraphQL itself aren't just financially compensated, but are made sure that they aren't having to give up something. Make sure that we provide some flexibility for the folks who do that great work.
Lee, I got a question from our viewers. This comes from Ilya, and they're asking, could you talk a little bit about the history of directives in the spec? It really looks like it was added as an afterthought, since even AST is very different. Sorry for butchering that.
Yeah, if Ilya has follow-ups, let me know in case you dropped a piece of the context. I'm happy to give some of the context there. I'll give a brief history. So GraphQL, I would say, went through 3 major phases of design. Phase 1 was 2012 through 2015, and I would say that would be we'll call it like GraphQL V1 or in Facebook GraphQL or something like that, which was the very first version of GraphQL that we designed within the company. And out of the gates, I would say we did a pretty reasonable job. Most of our design decisions from 2012 have lasted all the way to today, nearly 10 years later. But in that 3 years from 2012 to 2015 is when we were, that's the time period where we were doing that design review and federating that out, and a lot of stuff happened really fast. We did not have GraphQL mutations. We did not have interfaces or unions. We did not have a lot of things. We didn't have named arguments. There's just like a ton of stuff that we did not have. We didn't even have fragments. So if you wanted to repeat some piece of query, you literally had to copy and paste it. And over the course of those 3 years, we patched in features, right? Like our customer base for GraphQL were other engineers at the company. And so we knew that if we made a mistake, we would just fix it. We'd change it again. And so our change threshold was relatively low. And there was a lot of exploration really quickly. By 2015, we had something that didn't make a ton of sense. There was a lot of design inconsistencies within it. It had kind of gelled to a state where it was hard to make changes anymore. And people largely viewed GraphQL as complicated, and especially the query language is complicated. So in 2015, this was right around the time where the Relay project was also getting some traction. Actually, the Relay team wanted to open source what they had built, but it made no sense to open source Relay if GraphQL was not also open source. At the time, I think we really undervalued just how important GraphQL could be, and thought open sourcing would maybe be not the best use of our time. Luckily, please thank the Relay team. They convinced us that we should open source GraphQL, which is what we did. But I looked at what we had and said, this is a little bit of a mess. If we open source what we have, I don't think this will work. And then also, like, what the heck would that even mean? Are we going to go ship a PHP library? Like, most people don't use PHP, so it's probably going to be largely ignored or treated as like, oh, GraphQL, that's some like PHP thing, right? It's like not where I wanted that to end up. So that was when we started a redesign. We'll call it GraphQL V2 or open source GraphQL as opposed to Facebook GraphQL. And kind of like stripped it all the way back to its bare essentials and put it back together again. And this is actually where our RFC process came from, because when I led this process. I didn't do it alone. I was doing a lot of the design work, but all of my GraphQL team were the editors in this. So I would write proposals to say, like, here's how we should do this. We did it this way before, old. Here's how we're going to do it new. And I would get a ton of feedback on that. I'd iterate. I would say 2/3 of my proposals got killed and 1/3 survived. And the result is the GraphQL we all know and love. The accumulation of those proposals that were accepted by my teammates was a pretty different version of GraphQL. Syntactically similar in many ways, but very, very different set of features. It actually took Facebook nearly 2 years to convert from old school Facebook GraphQL to open source style GraphQL. They're there now, but it took a little bit. Getting back to the question, directives was one of those proposals. So directives was not part of the original 2012 version, nor did it appear anytime between 2012 and 2015, largely because directives shows up in two places. They show up in the query language itself, and then they also show up in the schema definition language. So schema definition language actually was not even part of the original open sourcing of GraphQL, just the query language was. We added that the following year. But within the query itself, this was a solution that I proposed because of a long tail. We had a bunch of experimental features for our internal version of GraphQL, Facebook GraphQL, with varying degrees of usage. And I would say the most important of those that got a lot of usage was skip and include. So you could decide that a field should be skipped or explicitly included with a Boolean variable that you could pass up from the client. And the way that that used to be described was as an argument. That seemed really weird to me, that like the same arguments that you pass in as data into your resolver is syntactically identical to this like special case argument called skip or include. And then there were a handful of other experiments streaming. Actually, even at that point, we had an experiment with streaming where stream was like a weird annotation in the form of an argument. And we had a couple other things that showed up as like syntactical additions. My concern was that anytime we wanted to try one of these experiments, and we had to muck around with the syntax itself, that put a very high bar on running an experiment. And so directives was a way to say, this is a way out. You don't have to change the syntax at all, and you can experiment with a bunch of stuff. So in the sense that it feels a little bit tacked on, it's kind of true. It was like it didn't survive for the first 3 years of GraphQL's existence. It was added on as part of the open sourcing effort, but it was designed. It was intentional. It was to say, here's the handful of things that we're already doing that should have an explicit syntax. But rather than that syntax being the skip and include syntax, like it should be a door that allows you to open into a wide world of user provided capability. When we added the schema definition language, we made sure to bring directives over to there as well. And I'm happy we did, because that's how federation works. That's how a lot of code generation tooling works. That's, a ton of people leverage directives for exactly the reason that it was originally designed, which is to add additional information and capability beyond what GraphQL itself describes.
Ilya had a follow-up. For example, list AST node for schema and directives are very, very different. Are there any plans of fixing this in the future? I realize that's very, very hard. Varies were in all caps.
A list AST is different from a directive AST. You might have to follow with me later. I don't know if I understand the question.
Completely understood. Ilya, we encourage you to reach out to Lee on Twitter.
Yeah.
Conversation never stops here, of course. And this, as always, is a great space to get access to you all for a little bit and ask questions and hear what's going on in the community. And I think on behalf of the community, I would like to thank you all for coming today and sharing all your amazing insight on all the different things that are happening in the GraphQL ecosystem and community. I know we weren't able to cover everything. I'm sure we could sit here all day and talk about it, though. So, like always, the conversation doesn't end here. It continues beyond. You can find all of us on Twitter, I'm sure. If not, anybody not on Twitter, there's also the GraphQL community Discord. I don't have that link available, but I will grab it real quick and share it.
Discord.graphql.org.
Discord.graphql.org. Done. So yeah, if you're not part of the conversation, not part of the community, definitely come join us. Tanmai, anything you want to share in closing?
No, I think that was I think that's a good conclusion to the session, and thank you everyone for joining us for the great conversation so far. And see you again, I guess, in a few months when we do one of these again with the latest and greatest updates that are happening. I think a few interesting GraphQL events also happening this week, right? There's GraphQL Galaxy, I think that starts. Uri, is it starting tomorrow? Has it started today?
I think workshops are tomorrow.
Okay,
I need to give a workshop tomorrow, so yeah.
Awesome. Cool. So there's a bunch of GraphQL stuff happening in the community that all of you all should tune into as well. But otherwise, thanks a lot for being here, folks.
Awesome. Thank you, everybody. And we will see you all at the next one.
Thank you so much.
Bye.
Bye.